Hello, students. Welcome to this lecture on statistics. In this lecture, we will cover NCERT section 13.4.2 and example 6 to 7. This is disclaimer. So we will start our discussion on mean deviation, which is a measure of how much the values in a data set differ from the average value. Then we will discuss mean deviation for ungrouped data. Then we will move on to mean deviation for group data. Then we will look at the discrete frequency distribution. Next, we have the continuous frequency distribution. Then we will start our discussion on mean deviation. Okay, so there we will see shortcut method for calculating mean deviation about mean. Lastly, we will look at examples 6 to 7 to see how these formulas work in practice. So let's get started. Let's start by understanding what a continuous frequency distribution is. In statistics, continuous frequency distribution is a series in which the data are classified into different class intervals without gaps along with their respective frequencies. Now, let's look at how to calculate the mean deviation about the mean for a continuous frequency distribution. So this method helps us measure how much the data values typically differ from the average value or mean of the distribution. When we calculate the mean for a continuous frequency distribution, we assume that all the data in a class interval are centered at the midpoint of that interval. So this simplifies our calculations and it is a standard approach in statistics. So for data that is grouped into class intervals, we follow a specific process to find the mean deviation. So let's go through the steps one by one so you can see how it's done. Step 1 is to find the midpoint, which we call xi of each class interval. Step 2 is to calculate the mean while we write it by x bar. So the formula for the mean is x bar equal to sum of a5 into xi divided by n, where n is a total frequency. N is the total frequency or the sum of all a5s. Here a5 is the frequency of the ith class and xi is the midpoint of that class. So x bar equal to f1 into x1 plus f2 into x2 plus dot 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 plus fn into xn divided upon f1 plus f2 plus dot 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 plus fn. Step 3 is to calculate the absolute deviations of each midpoint from the mean. That means for each class, we find the difference between the midpoint xi and the mean x bar and then take the absolute value and it's written as mod of xi minus x bar. Step 4 is to multiply each absolute deviations by its corresponding class frequency. In other words, for each class, we calculate a5 times absolute value of xi minus x bar. So now let's look at how to calculate the mean deviation about the mean. So first we need to sum the products of the frequencies and the absolute deviations from the mean. Okay, so sum of these products, that is summation E5 times mod of xi minus x bar. Step 6 is to divide by the total frequency n. So mean deviation about mean is equal to summation A5 times absolute value of xi minus x bar divided by total frequency n, where n is total frequency, which is simply sum of all the frequencies in our data set. Okay, in symbol n equal to summation A5. And A5 are the corresponding frequencies of each class interval or data value. And xi is the midpoint of each class interval. Finally, x bar is the mean of the data, and it's calculated using the formula x bar equal to summation A5 into xi divided by n, where n equal to summation A5. Now, let's look at an example. So in this example, we have to find the mean deviation about the mean for the following data. So in this table, in the first row, we have marks of 10, and in second row we have number of students. Okay, so first of all, try it yourself how to find the mean deviation about the mean of the following data. So let's solve this example step by step. So we need to find mean deviation about mean using formula mean deviation x bar equal to summation A5 multiplied with absolute value of xi minus x bar divided by n, here where n is the total number of students. So where x bar is mean and x bar equal to summation A5 into xi divided by n, where n is summation A5 and A5 are frequency of data, xi are the midpoints. We need to organize the data for calculation. So we will create a new table that includes the midpoint of each class interval, which we will call xi, and then multiply each midpoint by the corresponding frequency A5 and to get A5 into xi. So this helps us prepare for calculating the mean. So let's see how the table is set up. So look at this table. In this table, in first row, we have class interval of marks of 10. Then in first column, we have this. And then in second column, we have number of students. That is our frequency of the given data. And then in third column, we have midpoints. That is xi. And then we calculated here A5 into xi for each midpoint xi and their corresponding frequencies. And here you can see summation I equal to 1 to 7, A5 is 40, and summation I equal to 1 to 7, A5 into xi is 1800. Here, n is summation I equal to 1 to 7, if I equal to 40, and summation from I equal to 1 to 7, A5 multiplied with xi is 1800. And we know that the formula for the mean of group data, that is x bar equal to 1 by n summation from I equal to 1 to 7 if I multiplied with xi. It implies x bar equal to 1800 divided by 40, which equals 45. So the mean marks obtained by the students is 45, and this value will be used in the next steps to calculate the mean deviation. Now, to solve this, we need to add two more columns to our table. Okay, so the first new column is the mean deviation for each class interval, which is calculated as xi minus x bar, where xi is the midpoint of each interval and x bar is the mean. The second new column is fi times the absolute value of xi minus x bar, which means we multiply the frequency by the absolute mean deviation for each group. Here the mean x bar has already been calculated as 45. So look at this table. Okay, so in this table calculated we calculated mean deviation, absolute value of xi minus x bar, and then we multiplied the corresponding frequencies and mean deviation more absolute value of xi minus x bar. Okay, so here in the last of this table, you can see summation I equal to 1 to 7 if I is 40, summation I equal to 1 to 7 if I into xi is 1800, and summation I equal to 1 to 7 if I multiplied with mod of xi minus x bar is 400. Now, from the table, we can see that total number of students, which we call n, is the sum of all frequencies. So n equal to 2 plus 3 plus 8 plus 14 plus 8 plus 3 plus 2. Okay, and here n equal to total is basically 40. So we are also given that the sum of the products of frequency and the absolute deviation from the mean is 400, written as summation if I into mod of xi minus x bar equal to 400, and the mean x bar is given as 45. So these values will help us calculate the mean deviation. So we know that mean deviation about mean x bar is 1 by n summation I equal to 1 to n if I multiplied with absolute value of xi minus x bar. Okay, and here n equal to 7, and it implies summation I equal to 1 to n if I multiplied with a mod of x pi minus x bar. This is equal to summation I equal to 1 to 7 if I multiplied with xi minus x bar. Now, let's substitute the values into our formula. So we have mean deviations x bar equal to 1 by 40 multiplied with 400. So when we multiply, we get mean deviation x bar is 10. Therefore, mean deviation x bar is 10. I hope this example is clear to all of you. So now let's move to the next slide. Now we are focusing on a shortcut method for calculating the mean deviation about the mean in statistics. So this method helps us save time and effort. Okay, so especially when dealing with large data sets, we will see how shifting our calculation can make things much simpler. So now we will see shortcut method for calculating mean deviation about mean. So let's start by understanding why we use the step deviation method. Okay, so instead of working with the actual data values, so this method lets us simplify the calculation by using easier numbers. So here's how. Okay, The first step is to choose an assumed mean. So pick a middle value from the data set. Next, we calculate the deviations. So for each data point, we subtract the assumed mean. Now we shift the origin. So this means we imagine moving the starting point or 0 on the number line to our assumed. So by using this shortcut, our calculations become much simpler and faster. So here the diagram 13.3 shows how shifting the origin to the assumed mean helps us visualize the process. If there exists a common factor among all the deviations, so we can simply them further by dividing each deviation by the common factor. Now, when we divide each deviation by the common factor, the new values we get are called step deviations. So you can see an example of this process in figure 13.4. To make our calculation even simpler, we use what's called the step deviation method. Here we introduce a new variable di, which is calculated as di equal to xi minus a divided by h, where xi is the original value, a is the assumed mean, h is the common factor. Finally, let's see how we use these step deviations to find the mean. So the formula is x bar equal to a plus h multiplied with summation di into a phi divided by n. So let's see how di works. Okay. So first we need to choose an assumed mean, which we call a. The assumed mean is usually a value from the data set that makes calculations easier, often a central or convenient number. So this step helps us work with smaller numbers in the next calculations. Next, we calculate di for each value in our dataset. The formula is di equal to xi minus a, where xi is the actual data value and a is the assumed mean we just choose. Then find the summation di into fi. Then we calculate the mean x bar using the formula. So this method reduces the size of the numbers, making calculations easier and faster. Now, let's take an example. So in this example, we have asked to find the mean deviation about the mean. So the table shows marks obtained in the first row, and in second row we have number of students. Okay, so the marks obtained in the class intervals like 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70, 70 to 80. Okay, and then there we have in second row the number of students in each interval. Okay, so in interval 10 to 20, number of students is 2. In interval 20 to 30, number of students is 3. In interval 30 to 40, the number of students is 8. And in interval 40 to 50, number of students is 14. And in interval 50 to 60, number of students is 8. In interval 60 to 70, the number of students is 3. And in interval 70 to 80, number of students is 2. Now we will solve this example step by step. To solve this, we will use the step deviation method, which simplifies calculations when class intervals are equal. Here, we choose the assumed mean A equal to 45 because it's the midpoint of the central class interval, which is 40 to 50. So the step size H is 10 since each class interval spans 10 marks. So the question asks us to find the mean deviation about the mean for a set of marks obtained by students. So notice the table. The first row shows the marks intervals like 10 to 20, 20 to 30, 30 to 40, 40 to 50, and so on. Okay, and the second row shows how many students scored within each interval. So let's solve this example step by step. Now, let's represent the data in a more detailed tabular form to help with our calculation. So see here, this table, here is the completed table. So for each class interval, we have the number of students, the midpoint xi, the calculated di values, and the product of a phi di, where a phi is the frequency for each class. So at the bottom, we see the totals. The sum of frequency is 40 and the sum of a phi di is 0. From the table, we can see two important values. The sum of di times fi, and which is written as sum of di into fi equal to 0, and the total number of students n equal to summation fi, I equal to 1 to 7, this is equal to 40. Now, let's recall the formula for the mean using the step deviation method. X bar equal to a plus h multiplied with summation I equal to 1 to 7 di into a phi divided by n. Let's substitute the values into our formula. So x bar, this is 45 plus 10 multiplied with 0 divided by 40, and this is simply equal to 45. Now let's break down the calculation in detail. So we have added several columns in the table. The number of students column is our frequency, fi, the midpoints xi are the average of each class interval. For example, 15 for 10 to 20, and the column di is calculated by using the formula xi minus 45 divided by 10. Okay, and then in the next column, we have calculated a phi multiplied with di, and then in next column, we calculated absolute deviations. Okay, absolute deviations of xi minus x bar, and then we calculated a phi multiplied with xi minus x bar. Okay, and in the bottom of this table, we calculated totals n equal to summation I equal to 1 to 7, a phi is 40, summation I equal to 1 to 7, a phi di is 0, and summation I equal to 1 to 7, a phi multiplied with xi minus x bar is 400. Now, let's recall the formula for mean deviation about the mean. It is mean deviation x bar equal to 1 by n multiplied with summation I equal to 1 to 7 a phi multiplied with xi minus x bar. It implies 1 by n summation I equal to 1 to 7 a phi multiplied with xi minus x bar, a phi multiplied with absolute value of xi minus x bar. This is equal to 1 by 40 multiplied with 400, and this is equal to 10. Therefore, mean deviation about mean is 10, and this is our final answer. Now, we are talking about how to calculate the mean deviation about the median for a continuous frequency distribution. To find the mean deviation about the median for a continuous frequency distribution, we need to follow a specific sequence. So the first step is to arrange the data in order. This means we organize the class intervals and their frequencies in ascending order from the smallest class interval to the largest. Next, we need to find the median class. To do this, we calculate the cumulative frequency for each class and identify the class where the cumulative frequency first becomes greater than or equal to n by 2, where n is the total frequency. Now, let's calculate the median using the formula median equal to L plus n by 2 minus C upon F multiplied with H, where L is the lower limit of the median class, F is the frequency of the median class, H is the width of the median class, C is the cumulative frequency of the class before the median class. After finding the median, we calculate the deviations. So for each class, we find the midpoint, which is the average of the lower and upper class limits. So then we find the absolute differences between each midpoint. Okay, so the median m written as mod of xi minus m. Let's look at how to calculate the mean deviation. Here is the formula for mean deviation about the median. The mean deviation is given by 1 by n summation I equal to 1 to n if I multiplied with absolute value of xi minus m, where n is the total frequency and if I is the frequency of each class and xi is the value of each middle value of each class and m is the median. In simple terms, find the median, calculate the absolute differences from the median for each class and then find the average of these differences. So let's look at an example. In this example, we have to calculate the mean deviation about median for the following data. So here in the table, we have given two rows. The table shows in first row class intervals like 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60. Okay, and in second row, we have frequency like for class interval 0 to 10, frequency is 6. For class interval 10 to 20, frequency 7, and so on. So first of all, try it yourself. So we will solve this example step by step. To solve this, we need to use the formula for mean deviation about the median. So the formula for mean deviation about the median is mean deviation is equal to 1 by n sum of fi multiplied with absolute value of xi minus m, where I equal to 1 to n, where n is the total frequency, if I is the frequency of each class, m is the median. First, let's organize the data to make our calculations easier. So look at this table. In this table, we calculated cumulative frequency and midpoint xi. And in the bottom of the table, we calculated total of frequency, that is summation I equal to 1 to 6, fi is 50. Next, let's expand the table to include cumulative frequency and midpoints for each class. Okay, so here you can see the data of class. Okay, class interval frequency fi, cumulative frequency cf, and midpoints xi. So we clearly have total number of observations n equal to summation I equal to 1 to 6 fi equal to 50. So this is written as n equal to summation if I from I equal to 1 to 6. So you should keep in your mind this. First, let's identify the median class. So to do this, we need to find the class interval that contains the n by 2th item. So where n is the total frequency, here n is 50, so n by 2 is 25. The class interval that contains the 25th item is 20 to 30. Therefore, the median class is 20 to 30. Now, let's recall the formula for the median in a continuous frequency distribution. The formula is median equal to L plus n by 2 minus C divided by F multiplied with H. Here, lower limit L is 20, cumulative frequency C equal to 13, and F equal to 15, H equal to 10, and N equal to 50. Therefore, median equal to 20 plus 25 minus 13 multiplied with 10 upon 15. And after simplifying, you will get this is equal to 20 plus 8 and this is equal to 28. Now, let's examine the completed working table. We have added columns for cumulative frequency, midpoints, okay, and A5 multiplied with xi minus median. Next, let's recall the formula for mean deviation about the median. The formula for mean deviation about the median is given by mean deviation m equal to 1 by n summation I equal to 1 to n if I multiplied with absolute value of xi minus m. Finally, when we calculate 1 by 50 multiplied with 508, then we get 10.16. So mean deviation m equal to 10.16. So that's all for today's lecture, and thank you for your attention. I hope this lesson was helpful to all of you.